Hi everybody, I'm Greg Fishel, and this is a special video recapping the events of a tragic weather situation near Lucama, North Carolina last night in the middle of the night, just before 3 a.m. And unfortunately, I have found out that there was one fatality with a home collapsing apparently on a man. And they were hoping they were going to find him alive, but unfortunately that was not the case. There are a number of homes very badly damaged or destroyed, and Springfield Middle School also very heavily damaged as well. So I wanted to show you what this looked like on radar and the tools that meteorologists use to issue warnings to try to minimize the loss of life. And the National Weather Service in Raleigh is truly one of the best in doing this. But the problem is when something like this happens in the middle of the night, it's very, very difficult sometimes to get the word out. So this is the radar image at 2:49 a.m. From the National Weather Service Doppler radar, and you can see the radar over in here, this black dot. That's what we call the cone of silence, because the radar can only tilt its beam up so high. And so there's always an area right around the radar, very small area, that you can't see anything. And this is why having a network of radars is so important, because those areas, the surrounding radars, can look at that spot if there's something bad going on there, and their cone of silence is where they are and not where this one is. So having a network of radars is very, very important. But anyways, this is where the radar is located near Clayton, North Carolina. And here is Lucama. And here I have labeled the exact lat long where the damage actually was reported. So as you can see here, there was very, very high reflectivity values. In other words, the radar beam was going out from the radar like this, and then it was bumping into a plethora of raindrops or other objects. And then, of course, it's like an echo. It's like it bounces off those objects and comes back. And because you know how fast the radar beam is traveling and how long it took to go out, hit the object, and return, you can then calculate how far away that object is. But those of you that are weather hobbyists probably know that a lot of times tornadoes are associated with what we call hook echoes, which is a very well-defined pattern in the reflectivity that looks like a hook. And you really don't see that here. It just looks like a batch of really, really heavy rain. And this is why there are other tools that you look at. And so let me go on ahead here and switch to what we call the storm relative velocity image. And I'm going to have to go back here because it always resets to the original time. And so here, you can see that as the system was approaching Lucama, you have this classic, what we call inbound-outbound couplet, okay, where the radar is looking in this direction, and the red colors represent objects that are moving away from the radar, and the green ones are moving toward the radar. So when you have high velocities being detected that close to each other, that tells you that you have a circulation present there. Now, it doesn't necessarily have to be a tornado. It can be what we call a mesocyclone, but this one is so tight, okay, that it was a tornado in this case. And of course, we know that from the ground truth. And interestingly enough, and admittedly, the timestamps on these radar images can be just slightly delayed, and so it may not be the exact time that you're seeing on the screen up there. But as we move this on ahead, you can see that the circulation, once we got to where I have the tornado labeled there, actually fell apart. Okay, so this was occurring right at the end of the most intense part of this particular storm. Now, I want to go up here and show you another product which was even more obvious, I guess, or made it more obvious what was going on. And let's see, I'm going to turn this off here so we can get the cities back on. And then I'm going to show you something called the correlation coefficient. And by the way, I want to let you know, all this is courtesy of an app called RadarScope. And it is just a phenomenal radar app. It gives you access to all the National Weather Service Doppler radars all over the country, and also some terminal Doppler radars that are located at airports, and they update even more frequently than the National Weather Service Doppler radars do. There are varying subscription levels. I subscribe because of what I do for a living to the highest level so that I can have archive data back for a long time. And so this enables me to show you historic data where if I just had the basic subscription, I would not be able to do that. But what the correlation coefficient does is that it takes a look at the uniformity and the size of the objects that it's looking at. And so if it's all rain, then the size of those raindrops is going to be fairly uniform. If it's all snow, it's going to be fairly uniform. But if you have debris that is flying through the air, then you are going to have very different sizes of objects. So let me go back here again, and you can see where I've got the, okay, you see that right there, right over the area that I have labeled tornado? This means that the uniformity and the size of the objects that the radar is detecting is varying widely, okay? Everything is fairly uniform in here where you see the general reds and a few speckles of yellows, but right in here, this is a telltale sign. This is what we call a tornado debris signature, or TDS is the acronym for that. And so it was very clear that something bad was going on here. And the other thing is the radar beam is getting higher above the ground as you go away from the radar. There are two reasons for that. Number one, the radar beam is elevated at 0.2 degrees, okay? Because if it's purely horizontal, it's going to have a better chance of bumping into objects near the ground, which you don't want. So it's tilted up just a little bit. And on top of that, and this is really more important, the Earth is curving away from the radar as you go out. And so by the time the radar beam hit this area here, it was 700 feet in the air. So that debris was 700 feet in the air, and it may have even been higher than that. In fact, I can actually go up here a couple of tilts. Let's see, that's, now I need to go back again. I'm going to go up to the highest tilt that I can, and then I'm going to go back. And let's see here. Oops, the time got messed up there. Okay, well, yeah, that is at tilt 4, so it's showing up even at higher elevations than 700 feet. So this is really quite a remarkable system in the fact that it was able to lift those objects to that elevation above the ground. So this is a really, really good tool, and it used to be that, you know, we weren't able to confirm tornadoes unless somebody saw them with their eyeballs, and now with this kind of a product, it tells us a lot more. It's still not, in my opinion, quite as good as human eyeballs seeing it in real time, but it's very, very close. Now, if we go back to the live time here, this is what's going on now, and by the way, the current time is 10:40, and I'm going to zoom back out here, and I'm going to go to the traditional reflectivity value, and also go down to tilt 1. And let me zoom out here just a little bit more. And then if I animate this, you can see that these bands are continuing to wrap in from the south and east, and there is a current tornado warning up in here. See if I can get some information on that. That is a tornado warning remaining in effect until 11 for southern Warren, north central Nash, west central Halifax, and northeastern Franklin counties. At 10:36, a severe thunderstorm capable of producing a tornado was 8 miles northwest of Dorches, or about 9 miles north of Nashville, moving northwest at 35. Again, any of these storms, especially since we have a history now that these storms are capable of producing strong tornadoes, we really have to take these warnings very, very seriously. And this red area here that you see is a tornado watch. And let me see if I can get some information on that. Usually when I click on this little border here, it'll come up. There we go. Oh, I'm sorry, that's a flash flood warning. It's not letting me view the tornado watch area for some reason. Let me try down here. Yeah, there it is, okay. So this is a tornado watch that is in effect until 1 p.m. and it basically covers, I'll zoom out here, quite a large area that goes all the way from the coast up to around the Triangle area, up into southeast Virginia, and then back down toward the Outer Banks. And this is to the right of the track of what is Tropical Storm Debby. And there are a lot of reasons why that right area is favorable for tornadoes. It has to do with the fact that friction is greater over land than it is over water, and so you tend to get more convergence in that area. And of course, when the air comes together, it goes up, and then you get the production of these strong thunderstorms that can produce tornadoes. So that's why that watch is in effect in the location that it's in, because it's to the right of the forecast track of Tropical Storm Debby. All right, folks, I know that was a lot, but I thought you might be interested in seeing a little bit more or learning a little bit more about what happened last night and how these spin-ups with tropical systems are very short-lived, but in this case, they could certainly be very, very devastating, even though they don't last a terribly long time. All right, folks, that's it for now, and we'll talk to you again at a future time. Take care.